Hello everyone. In this video, we are going to study about the concept of the groundwater and what are some terms which are associated with it. So let's start. So till now in the hydrology, we have studied that about the precipitation. And in the precipitation, the major form of the precipitation which is falling on the earth's surface, that is in the form of the rainfall, which is a form of the precipitation. Now this rainfall which is occurring, that will be hitting the ground level, and once it is striking the ground, then certain portion of it will be percolating into the ground. Now if that water is available within the top crust of the earth's surface, that means that is known as the soil water or the top water, which is present in the topmost layer of the earth's surface. But if this water which is getting percolated, if it is reaching very deep in the earth's crust, then that water which is stored in the ground because of the deep percolations, that is known as the groundwater. So this groundwater is the underground water that occurs in the saturated zone of the variable thickness and depth, which is below the earth's surface. Now what is this saturated zone that we will see in a while? Then cracks and the pores in the existing rocks and unconsolidated crystal layers, they make up a large underground reservoir where part of precipitation that is stored. So if let's say this is the rock, in addition to the one rock there are multiple rocks which are present. So if the water is falling down, then it will be finding its way through these pores or the cracks in the existing rocks, and therefore it will be making a large underground reservoir upon reaching the bed surface. Now this groundwater that is largely tapped for the irrigation purposes in India. So much so that about 46% of the total irrigated area in the India, it gets its irrigation water from this source of the water supply. And most of our minor irrigation schemes, they use this source for the supply of the water. So the area which is irrigated, if that is less than 2000 hectares, that is known as the minor irrigation. If the area getting irrigated, it is in between 2000 to 10,000 hectare, that is known as the medium irrigation scheme. And if it is greater than 10,000 hectares, then such schemes are known as the major irrigation schemes. Now besides its use for the irrigation, it is also used as a source of water supply for the municipal purposes. That means the water which is supplied for the domestic needs, that is known as the groundwater. Now this groundwater which is supplied to us, that is utilized through the wells and the tube wells. That basically the type of wells that you usually see, that is known as the open well, in which there is some cylindrical structure which is inserting in the ground, and based upon that we classify that whether it is a well or not. So in this there will be a certain level of water which is known as the water level in case of the open wells. And if we are using the tube wells, which are basically the boring ones and which is primarily used for the irrigation purposes. Now since the groundwater is available at the very large depth, so to lift that water we have to use certain lifting devices. Now that may be manual or using the animals or the source of power, that may be either diesel or electric, so that we can bring the underground supplies to the earth's surface. The open wells that I've drawn here, that is a traditional method of tapping the groundwater in the areas where the groundwater table is high. This manual, animal or wind, diesel or any source of supply for the power that can be used for lifting the water from the open wells. The use of the tube wells, however, that is the subsequent development in this technique of the tapping of the groundwater. Now, if we look at the zones of the underground water, so when this precipitation is occurring, this is representing the rainfall, so it will be striking the ground. Certain portion of the water that will be available in this top portion. Now, that is the water which is used by the roots of the crops. So this is the area from where the roots extract the water for their growth purposes. Mostly the rest of the water that is going straight in the saturation zone, which is also known as the groundwater zone. So up to a certain height the water will be stored in this, and that area or that zone is known as the zone of saturation. Below this there is a rock which is present, in which there will be no water whatsoever which will be present, and such region is known as the zone of rock, that is known as the zone of rock flowage, and rest of the area that is known as the zone of rock fracture. So what is consulting us, or what is for our consideration, that is the zone of rock fracture. Now within this zone of rock fracture we divide it into two portions, that is the portion where the water is available throughout the rocks or the soils. That means the water is saturated. This area is completely saturated with water, and that's why the name is known as the zone of saturation. In the rest of the area the water is not present. That means there will be air which will be present in the voids of the rocks, and because of that reason this is known as the zone of aeration. Now this zone of aeration is further classified it into three categories. So because of the small cylindrical tubes which are forming because of the voids of the rocks, there will be certain upliftment of the water up to a certain region, and that region where the water is present through the fringes, that is known as the capillary fringe water, or the Vadose region, or the suspended or gravity water. All of these are the names for this region within the zone of aeration. Then the rest of the zone of aeration is divided into soil water and the intermediate water. So as the water is moving down below the surface of the earth towards its center, it is existing in different regions, and at different depth earth crust is divided into two regions mainly, that is the zone of rock fracture and the zone of rock flowage. Now the depth of the zone of the rock flowage, that is the zone in which the rocks undergo permanent deformation, but that is not accurately known because that is at very greater heights, or that is at very greater depth, but it is generally estimated as many a miles. Now in this the interstices, that means the voids, are probably absent because there is a continuous rock which is present, and the stresses in this region are beyond the elastic limits, and rocks remain in a static or plastic flow. Whatever water which will be present within this region, that is known as the internal water, and we do not consider this as a source of water, and because of that a hydraulic engineer has nothing to do with this water. What is consulting us is the zone of the rock fracture. Now, in this zone, the stresses, they are within the elastic limits. That means if a rock is deformed, then it will be getting back to its original shape. And here the voids do exist. So the water is stored in the voids, the amount of which that depends upon a parameter that is known as the porosity. What is that? That we will see in the upcoming videos. The maximum depth of this zone below the ground surface, that varies from 100 meters to 1000 meters or more. Now, in case of the rocks in which the crystal structure is present, which is known as the crystalline rocks, most of the water that is met within the 100 meter of the surface. But in case of the sedimentary rocks, it is found up to the depth of 1800 meter, or at lesser values at up to 1000 meters. So we have already seen that this zone of rock fracture, it is divided into zone of saturation and the zone of aeration. The one which is below the water table, that is the zone of saturation, and the one above the water table, that is the zone of aeration. Now in the zone of saturation, the water exists within the interstices. That means that is present within the voids and is known as the groundwater, which is our consideration. And that is why it is most important zone for the groundwater hydraulic engineer, because he has to tap out this water. And water in this zone is always under the hydrostatic pressure. Then the next zone is the zone of aeration, in which the water is existing by the molecular attraction, while in the zone of saturation it was present freely in the voids. Now the gravity water which is moving through this zone, that is not at the hydrostatic pressure, and the region is usually marshy in this case, and the depth is up to 300 meters. And it is further classified into three classes depending on the number of stiches or the voids which are present. First one is the capillary fringe, which is the belt just above the zone of saturation, and it contains some amount of the water. Therefore, it is also known as the continuation to the zone of saturation. Then the depth from the surface up to which the roots are penetrating, that is known as the soil zone, and the remainder of the zone of aeration, or the area between the soil zone and the capillary zone, that is known as the intermediate zone. That is the area between these two existing zones. And that is how we classify the availability of the groundwater. Now in the next video, we will look at the occurrence of the groundwater, in which we will look at the different parameters which help us in identifying whether the water will be available below a area or not. Thank you.